Here we are going to discuss number 6 in the Math 1 to 2 Statistics 1, right? Unit 6, Assignment 6, number 6. It says list 10 important points found in Unit 6 on Math on page 5. 10 important points found in Unit 6 on page 5. So we have to go to Unit 6 on page 5. Here's Unit 6, right? That's it right there. Unit 6, the normal distribution. And we've got to go to page 5. This is page 2, page 3, page 4, and page 5. This is page 5. Apparently, there seems to be 10 important points. Where are they? Here are some important points. So please read these important points very carefully and list them. You remember, we see this practice paper or assignment is almost like a learning tool. Okay, so you're not basically using it to submit to get a map, but using it to learn about whatever the topic is. Specifically, we want to learn about normal distribution. So we've got to do some reading and so forth. So this is an encouragement to read. So there are some very important points here. So please read it and to submit. See, the normal distribution deals with continuous variables. To calculate probability values for variables which follow a normal distribution, you must make use of the mean, population mean, and the variance. Population variance. The probability values are obtained from a standard normal table after standardization has taken place using the formula Z is equal to X minus mu over sigma. I think that's where the letter Z came from the word standardized. Okay, this is a process where X variables are standardized into Z values. Okay, and you then go to the standard number table of probabilities given on page 6. In this table, mu is 0 and sigma squared is equal to 1. All right, and you always remember that P of Z less than or equal to Z can be written as phi of Z. So phi of Z is just another shortcut notation for P of Z less than or equal to Z. Apparently, the statisticians don't like to write too much for a particular concept. So instead of writing P of Z less than or equal to Z, you just write phi of Z. So that's just a replacement for, phi of Z is just a replacement for P of Z less than or equal to Z. Phi now is a Greek letter. Okay, I think it's PH, phi, phi, to pronounce, to spell phi, we use PH, and I think this is a symbol that they use, the Greeks. So it's just a letter, a Greek letter to replace P of Z less than or equal to Z. So therefore, P for probabilities, yes, of Z less than or equal to 1.6 is the same as phi of 1.6. Yeah. And also please note that P of Z less than or equal to Z is the same as P of Z less than Z in the normal distribution because the variable is continuous, it's not discrete. So there is no significant difference between the two because the variables are continuous. P of Z less than or equal to 1.6 can be read straight from the table, such that P of Z less than or equal to 1.6 is the same as phi of 1.6, which is 0.952. So where is the table? Let's look at the table. Is it higher up or lower down? I think it's lower down. Right, here's the table. And you want to find phi of 1.6. Okay, here it is, phi of Z. That means Z less than or equal to, P of Z less than or equal to this entire area there. And here it is written there again. And phi of negative Z is 1 minus phi of Z. Okay, because phi of negative Z. This table only gives phi of positive Z's. So all these Z's are positive. So you want to find P of Z, phi of negative Z, all right, less than or equal to negative Z is the same as 1 minus, okay, phi of Z. Okay, that would be like a tail. I call this is a a big chunk, and this is a little tail. So phi of negative z is like finding a tail. The left tail is the same as the right tail. Okay, so if you want to find a little tail, so therefore you find the big chunk and you subtract from 1 and it will give you a tail. Okay, so basically phi of negative z is a tail. And from this table, once you want to find a tail, you've got to find the big chunk or the big chunk and subtract from 1 and it will give you a tail. More than a p of more than or equal to z is also a tail, so it's 1 minus phi of z. So just note, once you want to find a tail, you've got to do a 1 minus. So you want to find phi of 1.6. So you look for 1.6. These are the z's. That's the first decimal place, and that's the second decimal place. And that's the add-on. We'll talk about more about this table later. Look for 1.60, 0.9452. So that's where that 0.9452 came about. All right, here it is. For situations such as phi of negative 1.6, which we just talked about a while ago, you find p of, that's like finding p of z more than or equal to 1.6, and p of z more than or equal to negative 1.6 will require some modification before you can go to the table. We'll talk about this more in detail. You can only use a table for p of z less than or equal to z, or phi of z where z must be a positive number. Okay, so that's how this table is structured. It's calibrated for positive z's. There are other tables calibrated for negative z's, you know. So if you go in Google and you type standard normal distribution tables, and you go to images, you'll get a whole set. Here, this one is calibrated for phi of negative z's. Okay. This one is for phi of negative z's. Where is it? There it is. But this one is phi of z. This one is phi of z. This one is just like the one we just did a while ago. I would swear in the image. I saw phi of negative z. And here's one where it is calibrated for probability values between 0 and z. So this is not phi of z. It only gives you this area there. Okay. So if you look for 1.6, you get 0.4452. There it is. And this is this area there it's giving you. All right. Between 0 and z. And you've got several others. Some are phi of, and some are positive z's, and some are negative z's. So these are the 10 important points. So read them carefully. In this video, we are going to discuss number 7 in the Math 1 to 2 Unit 6 Assignment 6. It says phi of z is equal to what? We can go to Unit 6 because since we have done number 6, we are familiar with those 10 important points on page 5 and the table. So phi of z, as we can see, here it is probability of z less than or equal to z. All right. This table is calibrated for phi of positive z. As we said in a previous video, there are tables that are calibrated for different areas. Some example like phi of positive z, some are between 0 and z, some are even calibrated for negative z's, Okay. And on top of the page of the probability table, it will tell you what probability values that it gives you. Okay. As you can see, there are several examples of them. And this is the table that we are going to use to solve any probability question. We must use the table because the formula is very, very cumbersome to use. So that is why the probability values are calibrated in tables. But there are softwares that you can use to help you also. So this table here, you see there's a formula. The formula is a little bit cumbersome to use. This table gives you areas. This table gives you a tail. So as you can see, all the probability values in that table are less than 0.5. Okay, because the entire area is 1. It is symmetric, so you have 0.5 on one side and 0.5 on the other side. So this table will only give you tails less than 0.05. Whereas the table we'll be using will give you a big chunk, not a tail, a big chunk. And as you can see, all the probability values are more than 0.5, starting with 0.50 and more. So as we're going higher up the scale, the probability values are increasing, starting from 0.50 is 0.5, and then up and up and up. So all these values, they are greater than 0.5 because this gives you a big chunk. It gives you a phi of positive, right? Phi of positive Z is a big chunk. It's not a tail. So here it is. That should help you with question number 7.